So I'm just going to read for 1 hour today. Going to read for 1 hour today. Chapter 4, Summary Increase. Quick review. The smallest unit of memory is a binary digit, also called a bit. The smallest unit amount of memory that can be addressed directly is a byte. The modern standard is that a byte equals 8 bits. A data type tells the compiler how to interpret the contents of memory in some meaningful way. C++ comes with support for many fundamental data types, including floating point numbers, integers, Boolean, chars, null pointers, and void. Void is used to indicate no type. It is primarily used to indicate that a function does not return a value. Different types take different amounts of memory, and the amount of memory used may vary by machine. The size of operator can be used to return the size of a type in bytes. Signed integers are used for holding positive and negative whole numbers, including 0. The set of values that a specific data type can hold is also called its range. This is an advertisement. When using integers, keep an eye out for overflow integer division problems. Unsigned integers only hold positive numbers and should generally be avoided unless you're doing bit level manipulation. Fixed with integers with guaranteed size, but they may not exist on all architectures. The fast and least integers are the fastest and smallest integers that are at least some size. Standard int 8 and standard uint 8 should generally be avoided, as they tend to behave like chars instead of integers. Size t is an unsigned integral type that is used to represent the size or length of objects. Scientific notation is a shorthand way of writing lengthy numbers. C++ supports scientific notation in conjunction with floating point numbers. The digits in the significant, the part before the e, are called the significant digits. Floating point is a set of type designed to hold real numbers, including those with a fractional component. The precision of a number defines how many significant digits it can represent without information loss. Rounding error can occur when too many significant digits are stored in a floating point number that can't hold that much precision. Rounding errors happen all the time, even with simple numbers such as 0.1. Because of this, you shouldn't compare floating point numbers directly. The Boolean type is used to store a true or false value. If statements allow us to execute one or more lines of code if some condition is true. Conditional expression of an if statement is interpreted as a Boolean value. Char is used to store values that are interpreted as an ASCII character. When using chars, be careful not to mix up ASCII code values and numbers. Printing char as an integer value requires use of static cast. Angled brackets are typically used in C++ to represent something that needs a parameterizable type. This is used with static cast to determine what data type the argument should be converted to. Convert X to an int. Standard string offers an easy and safe way to deal with text strings. String literals are always placed between double quotes. Standard string lives in the string header. A constant is a fixed value that may not be changed. C++ supports two types of constants: literal constants and symbolic constants. Literals are values inserted directly into the code. Literals have types, and literal suffix can be used to change the type of literal from default. Const variables are variables that can't be changed after being initialized. Const variables can be either runtime or compile time constants. Const expression variables must be compile time constants. Don't use magic numbers in your code, instead use symbolic constants. Quiz time, question 1. Why are symbolic constants usually a better choice than literal constants? why are expression symbolic constants usually a better choice than defined symbolic constants? So I think this is because of the debugging stuff with magic numbers. Because it's harder to, and because you have to change one by one if you want to change something in the code, and also to debug and sometimes you don't know what the number is for. Why are const express symbolic constants usually a better choice than defined symbolic constant? Because define can be declared into another header file. Then when you're gonna use const, when you're gonna use it, you're gonna have a problem of the function is not gonna do what you want it to do because it's getting the thing from other header files. I mean, is the other header files are not is not getting the functions from the other header files. I think that's the answer. Using literal constants, aka magic numbers, in your program makes your program harder to understand and harder to modify. Symbolic constants help document what numbers actually represent. Changing a symbolic constant at its declaration changes the value everywhere it is used. Hashtag defined constants do not show up in the debugger and are more likely to have naming conflicts. Question 2. Pick the appropriate data type for a variable in each of the following situations. Be as specific as possible if the answer is an integer pink int, size isn't important, or specified or specific fixed with size with integer type. In 16 based on range, if the variable should be const, say so. The age of the user in years, assume the size of the type is important. So this is gonna be an int. As the user wants the application to check for updates. I don't understand this question. We're just gonna look Boolean. Const expression level. Because is it a constant? And it's not gonna be dependent on runtime. The numbers of pages in the textbook, some size is not important. It's gonna be int if size is not important. Otherwise, it could be either depending on the book. Yeah. Either uint8 or uint16. Once I have more than 38 pages, int should be fine here. The length of a couch if it. Oh, yeah. So uint8 square. I thought uint8 was capable of holding only 256 values. So maybe I'm wrong about that. The length of a couch in feet to two decimal places. Some size is important. Double. Float. How many times you blinked since you were born? Note, answer in the millions. So this is gonna be uint something. Uint 64 maybe. And 32. Int 32. The user selecting an option from a menu by letter. By letter char. The year someone was born. Some size is important. I think it's int. Int 8 maybe. Oh. Int 16. Int 16, yeah. Can use positive numbers to represent AD birth dates and active numbers to represent BC birth dates. Author's note. The quizzes get more challenging starting here. These quizzes that ask you to write a program are designed to ensure you can integrate multiple concepts that have been represented throughout the lessons. You should be prepared to spend some time with these problems. If you're new to programming, you shouldn't expect to be able to answer this immediately. Remember, the goal here is to help you pinpoint what you know and which concepts you may need to spend additional time on. Find yourself struggling a bit, that's okay. Here are some tips. Don't try to write the whole solution at once. Write one function, then test it to make sure it works as expected, then proceed. Use your debugger to help figure out where things are going wrong. Go back and review the answers to quizzes from prior lessons in the chapter, as they will often contain similar concepts. If you're truly stuck, feel free to look at the solution, but take the time to make sure you understand what each line does before proceeding. As long as you leave understanding the concepts, it doesn't matter so much whether you were able to get it yourself or had to look at the solution before proceeding. Write the following program. The user is asked to enter two floating point numbers, use doubles. The user is then asked to enter one of the following mathematical symbols, plus, minus. Program computes the answer on the two numbers the user entered and prints the result. If the user enters an invalid symbol, the program should print nothing. So I don't think I'm gonna do these exercises for the same reasons as the previous ones. Maybe I should be doing that. Sorry to know. I don't think I'm gonna do it. Question 4, extra credit. This one is a little more challenging. Write a short program to simulate a ball being dropped off a tower. To start, the user should be asked for the height of the towers in meters. Assume normal gravity 9.8 and that the ball has no initial velocity. The ball is not moving to start. Have the program output the height of the ball above the ground after 0, 1, 2, 3, 4, 5 seconds. The ball should not go underneath the ground height 0. Use a function to calculate the height of the ball after x seconds. The function can calculate how far the ball has fallen after x seconds using the following formula. Distance falling equals gravity constant times x seconds to the power of 2 divided by 2. So this is an interesting thing that I'm not sure exactly how to specify that is meters per second to the power of 2. Because so far I haven't done anything that depends on physical meaning. So in a normal case, I would just initialize it with 9.8 as a value. But here I don't know if that would be necessary or it has to be if you're gonna solve physical problems, right? Because each constant has to be related to the magnitude of the constant for obvious reasons. But I'm not sure to specify that. Depending on the height of the tower, the ball may not reach the ground in 5 seconds. That's okay. Improve this program once we've covered loops. Note this symbol is an exponent in C++. Implement the formula using multiplication instead of exponential. Note, remember to choose double literals for doubles, e.g. 2.0 rather than 2. So I think one thing that comes to mind is make every letter on the scientific notation equals to a variable and then create functions to determine the conversion between them. That'll be probably a way. And then you just do value of the integer times the scientific notation. That's what I would do, I think. Not sure that if they're gonna touch on him. Yeah, they're just assigning to the 9.8. Tower height seconds. Print height. Yeah, so didn't talk about this. Note that calculate height doesn't print the height itself. Under best practice, that functions should do one and only one thing. Use a different function to do the printing. Find 3 issues affecting 4 lines in the following code. Simple output, older U6 allows you to drive a car in Texas. How old are you? 19 allows you to drive a car. Next. So is outputting the wrong age here? No, it's correct. So maybe this is the WS thing. Not sure. I don't remember really well. WS. When it was used for. Yeah, some of the things I'm forgetting already. What was standard dots WS? I don't think it's related to this, but trying to remember what was this used for. There's no reason to use standard int uint 80 and 8 if we were to print age. So here. It will be treated as a character by standard count. A regular int should be used to store the age. Age doesn't require a specific minimum integer width. Characters should be placed in a single quotation mark, not full quotation marks, line 14, 16. Characters should be placed in single quotation marks. 14 and 16. No, single, not full. Don't remember why exactly. This line should use this X and this not. Full quotation marks need more storage and cause slower functions to be called than if we use single quotation marks. Interesting. Although the meaning of 16 is clear from the context it is used in, 16 can be seen as a magic number. As per best practice, a const expression variable with the value 16 should be defined and used instead. Maybe I should look what's the, because I'm kind of curious. Discard leading white spaces from an input stream. Oh, yeah. But when it is used, There's something about yeah, get line. That's the thing, the function. Yeah, let me keep reading this stuff. Operator precedence and associativity. Chapter introduction. This chapter builds on top of the concepts from lesson 1.9 that quick review follows. Mathematics and operations is a mathematical calculation involving zero or more input values, called operands, that produces a new value, called an output value. Specific operation to be performed is denoted by a construct, typically a symbol or pair of symbols called an operator. For example, as children, we all learned operator precedence. Now let's consider a more complicated expression such as this. This is going to talk about mathematics. Operator associativity. What happens if two operators in the same expression have the same precedence level? The multiplication and division operators above precedence level 5. In this case, the compiler can't rely upon precedence alone to determine how to evaluate the result. If two operators with the same precedence level are adjacent to each other in an expression, the operator's associativity tells the compiler whether to evaluate the operators from left to right or from right to left. The operators in precedence level 5 have an associativity of left to right, so the expression is resolved from left to right. Table of operators. The below table is primarily meant to be a reference chart that you can refer back to in the future to resolve any precedence or associativity questions you have. Note, precedence level 1 is the highest precedence level, and level 16 is the lowest. Operators with a higher precedence level gets evaluated first. How big there are means left to right associativity, and the other way means right to left. Oh, it's not bigger, it's a narrow. Yeah, same thing. So global scope, pattern, class. This is important, I think. And it's really hard to remember. I'm not sure if this is gonna be too small to print. Maybe we should take two pictures instead. Is this the best way to precedence? You should already recognize a few of these operators, such as these ones, and size of. However, unless you have experience with another programming language, the majority of the operators in the table will probably be incomprehensible to you right now. As expected at this point, we'll cover many of them in this chapter, and the rest will be introduced as there is a need for them. Where's the exponent operator? C++ does include an operator to do exponential. Operator has a different function in C++. We discuss exponential more in lesson 5.3. Quantization. In normal arithmetic, you learn that you can use parentheses to change the order of application of operations. For example, we know that this expression evaluates as this one. But if you want it to evaluate as instead, you can explicitly parenthesize the expression to make. So this is obvious stuff. Best practice use parentheses to make it clear. A non-trivial expression should evaluate if they're necessary. Best practice expressions with a single assignment operator do not need to have the right operand of the assignment wrapped in parentheses. Warning: in many cases, the parts of a compound expression, including function calls and argument evaluation, may evaluate in any order. Compound expression, including function calls. No, the precedence associativity. If A is 1, B is 2, and C is 3, this expression will evaluate to the answer 7. However, the precedence and associativity rules only tell us how operators evaluate in relation to other operators. It does not tell us anything about the order in which the rest of the expression evaluates. For example, does variable A, B, or C get evaluated first? Perhaps surprisingly, in many cases, the order of evaluation of any part of a compound expression, including function calls and argument evaluation, is unspecified. In such cases, the compiler is free to choose any evaluation order it believes is optimal. In many cases, the parts of compound expression, including function calls and argument evaluation, may evaluate in any order. For most expressions, this is relevant. In our sample expression above, it doesn't matter whether in which order variables A, B, or C are evaluated for their values. The answer will always be 7. There's no ambiguity here. Just talking about this. For most expressions, but it is possible to write expressions where the order of evaluation does matter. Consider a program which contains a mistake often made by new C++ programmers. So if you run this program and enter inputs 1, 2, and 3, you might assume that this program would print 7. But that is making the assumption that the calls to get value will evaluate in left to right order. The compiler may choose a different order. For example, if the compiler chose a right to left order instead, the program would print 5 for the same set of inputs. Would it though? The compiler chose a right to left order instead. So 1, yeah, plus 2. No, but I don't understand. Right to left. Oh yeah, 1 times 2 plus, yeah. I get it. Best practice outside of the operator precedence associative rules assume that the parts of an expression could evaluate in any order. Ensure that the expressions you write are not dependent on the order of evaluation of those parts. Related content, there are some additional examples of cases where order of evaluation problems can occur in lesson 5.4. Quiz time question 1. You know from everyday mathematics that expressions inside of parentheses get evaluated first. For example, in the expression, part is evaluated first. For this exercise, you're given, yeah, not gonna do this. Arithmetic operators. Unary arithmetic operators. There are two unary arithmetic operators, plus and minus. As a reminder, unary operators are operators that only take one operand. The unary minus operator returns the operand multiplied by -1. In other words, binary arithmetic operators. There are 5 binary arithmetic operators. Binary operators are operators that take a left and right operand. Integer and floating point divisions. It's easiest to think of the division operator as having two different modes. If either of or both of the operands are floating point values, the division operator performs floating point division. Floating point division returns a floating point value and the fraction is kept. For example, as with all floating point arithmetics, this is redundant. Using static cache to do floating point division with integers. The above raises the question: if we have two integers and want to divide them without losing the fraction, how would we do so? Lesson 4.11, we showed how we could use the static cast operator to convert a char into an integer so it would print as an integer rather than a character. We can similarly use static cast to convert an integer to a floating point number so that we can do floating point division instead of integer division. Consider the following quote. So this answers the question I had before, which is if you can perform mathematical operations after you're doing static cast. So you have two integers, but you're casting them to double to make the division. Because the division is fractional. This produces the result. But I just don't understand why not do this by assigning the double. It seems like a lot of work for just doing things the simple way and making it a float or double. So I don't understand why this is used. But maybe there are a few exceptions that you need to declare as an int for one function and use it as float for another. So that might be the case. Because that is a more efficient use of memory, but I don't know. This produces the result. The above illustrates that if either operand is a floating point number, the result will be floating point division, not integer division. Dividing by 0. Trying to divide by 0 will generally cause your program to crash as the results are mathematically undefined. If you run the above program and enter 0, your program will either crash or terminate abnormally. Go ahead and try it and won't harm your computer. Arithmetic assignment operators. Up to this point, when you've needed to add var to variable, you've likely done the following. This works, but it's a little clunky and takes two operators to execute. Because writing statements such as x equals x plus 4 is so uncommon, C++ provides 5 arithmetic assignment operators for convenience. Instead of writing this, you can write x plus equal 4. Instead of this, you can write plus, yeah. So it's the same as in other languages. Thus the above becomes this. Modules and exponentiation. The modules operator, also informally known as the remainder operator, is an operator that returns the remainder after doing the integer division. I'm gonna skip this because I already know. Modulus with negative numbers. Modulus operator can also work with negative operands. Always returns results with the sign of x. When the above program, -6, 4, the remainder is -2. 6 is not evenly divisible by 4. In both cases, you can see the remainder takes the sign of the first operand. Where's the exponent operator? So here, that's always gonna take, because here 6 is becomes 2, because it's minus 6 it becomes minus 2 as the remainder. So the remainder takes the sign of the first number, first operand. Where's the exponent operator? Note that this operator commonly used to denote exponentiation mathematics is a bitwise XOR operation in C++. Bit manipulation with bitwise operator and bitmax. C++ does not include exponent operators. To do exponents in C++, hashtag include the CMath header and use the pol function. Note that the parameters and return value of function pol are of type double, due to rounding errors in floating point numbers. The result of pol may not be precise even if you pass it integers or whole numbers. If you want to do integer exponentiation, you're best off using your own function to do so. The following function implements integer exponentiation using the non-intuitive exponentiation by squaring algorithms for efficiency. So int fast 64 or int base int exponentiation. Standard int fast 64 result 1, while exponent while xp if xp and 1 results plus equals result times base xp greater than or equal than. I'm not sure if this is greater than. It seems like it's assigning the exponent to exponent 1. Base equals base times base. Don't worry if you don't understand how this function works, you don't need to understand it in order to call it. Yeah, but yeah, that's not satisfying at all. Must be no negative. So here it declares an int of result 1. And the while exponent, which is the number that's gonna pass for the exponent, if it's 1, result is the base. Yeah, result is the base. Because the result's gonna be 1 times the base is gonna be the base. And the analysis is gonna be exponent equals. I don't understand this part here. I think it's stacking the exponents. Because this is gonna loop until it reaches the exponent value, maybe. Base times or equal base. Then here, same thing. And then just using this to call it. Warning, in the vast majority of cases, integer exponentiation will overflow the integral type. This is likely why such a function was included in the standard library in the first place. Quiz time. What does the following expression evaluate to? So I'm not sure which one comes first here. If it is the multiplication or the remainder. I would have to check the table there, the reference table. But here is gonna return the remainder is 1, 5, 11. And let's see if this is correct. Because have a and the module have higher precedence than plus, the positive will evaluate less. We can write our expression as this. Operator this and this have the same precedence. So we have to look at the associativity to resolve them. The associativity for operators is left to right. So we resolve the left operator first. So it's gonna be 20 divided by 3. It's gonna be 6. But it's the remainder. You can write our expression like this. So 6 plus 20 times 3. 20 divided by 3. Isn't that 6? Oh, yeah. Oh, that doesn't make sense. Because 6 times 3 is 18. And then you're gonna have break there. So don't understand why the remainder is 2. Oh, yeah. It's because it's 18. 20 minus 18 equals 2. I'm tripping. I thought there would be... Yeah. No. Write a program that asks the user to input an integer. It tells the user whether the number is even or odd. Write a function called isEven that returns the true if an integer passed through it is even or false otherwise. I'm not gonna do this. Note may have been tempted to write a function isEven like this. While this works, it's more complicated than it needs to be. Let's take a look at how we can simplify it. First, let's pull out the if statement conditional and assign it to a separate boolean. Oh no, yeah. Increment decrement operators and side effects. Incrementing and decrement variables. Incrementing and the one variable are both so common that they have their own operators. Note that there are two versions of each operator. This prints this. The postfix increment decrement operators are trickier. First, a copy of the operand is made, then the operand, not the copy, is incremented or decremented. Finally, a copy, not the original, is evaluated. X is incremented to 6, copy of original X is evaluated to the value 5, and 5 is assigned to Y. This prints 6 and 5. So it increments and makes X equals 6, then Y becomes 5. That's interesting. Don't understand why the 5 gets assigned to Y. Let's examine how this line 6 works in more detail. First, a temporary copy of X is made that starts with the same value as X5. Then the actual X is incremented from 5 to 6. Then the copy of X, which still has value 5, is returned and assigned to Y. Then the temporary copy is discarded. Consequently, y ends up with a value of 5. The pre-incremented value and x ends up with the value 6, the post-incremented value. Note that the post-6 version takes a lot more steps and thus may not be as performant as the prefix version. Here's another example showing the difference between the prefix and post-6 versions. This produces the output 5, 5, 6, 4. I think I kind of get it, but yeah, this one is 6, 4 again. Don't understand why. But they are the same of this. Should be 5, 5 again. So this changes the value to 6 and 4. So the value stays 6 and 4 now. But according to the other stuff, it should be the initial value. This is what I don't understand. Or maybe because it is not, the copy wasn't made, so that's why. So yeah, get it. On the 8th line, we do prefix increment and decrement. On this line, x and y are incremented and decrement before the values are sent to standard count. So you see their updated values reflected by standard count. On the 10th line, we do a postfix increment and decrement. On this line, the copy of x and y with the pre-incremented, the pre-decremented values are sent to standard count. So we don't see the increment and decrement reflected here. Those changes don't show up until the next line when x and y are evaluated again. Best practice strongly favor the prefix version of the increment and decrement operator, as they're generally more performant. The prefix version of increment. I assume this is this one, not the previous one. Yeah. As they're generally more performant, and you're less likely to run into strange issues with them. Side effects. A function of expression is said to have a side effect if it does anything that persists beyond the life of the function or expression itself. Common examples of side effects include changing the value of objects, doing input or output, or updating a graphical user interface, enabling or disabling a button. Most of the time, side effects are useful. Assignment operator modifies the state of x. Operator plus plus modifies the state of x. Operator modifies the state of the console. The assignment operator in the above example has the side effect of changing the value of x permanently. Even after the statement has finished executing, x will still have the value of 5. Similarly, with operator plus plus, the value of x is altered even after the statement has finished evaluating. The outputting of x also has the side effect of modifying the state of the console, as you can now see the value of x printed to the console. However, side effects can also lead to unexpected results. C++ standard does not define the order in which function arguments are evaluated. If the left argument is evaluated first, this becomes a call to add 5, 6. So int value, okay, which equals 11. If the right argument is evaluated first, this becomes a call to add 6, 6, which equals 12. Note that this is only a problem because one of the arguments function add has a side effect. I don't understand why people do this as well. Seems like you start setting yourself up to making a bunch of problems. As an aside, the C++ standard intentionally does not define these things so that compilers can do whatever is most natural and thus most performant. for a given architecture. There are other cases where the C++ standard does not specify the order in which certain things are evaluated, such as operator operands. So different compilers may exhibit different behaviors. Even when the C++ standard does make it clear how things should be evaluated, historically this has been an area where there have been many compiler bugs. These problems can generally all be avoided by ensuring that any variable that has a side effect applied is used no more than once in a given statement. C++ does not define the order of evaluation for a function, arguments, or operators or operator operands. You use a variable that has a side effect applied to it more than once in a given statement. If you do, the result may be undefined. Comma and conditional operators. Not sure if I need to put this here. The comma operator allows you to evaluate multiple expressions whenever a single expression is allowed. The comma operator evaluates the left operand, then the right operand, and then returns the result of the right operand. First, the left operand of the comma operator is evaluated, which increments x from 1 to 2. Next, the right operand is evaluated, which increments y from 2 to 3. The comma operator returns the result of the right operand 3, which is subsequently printed to the console. Note that comma has the lowest precedence of all the operators, even lower than assignment. Because of this, the following two lines of code do different things. This makes the comma operator somewhat dangerous to use. In almost every case, a statement written using the comma operator would be better written as separate statements. For example, that both code could be written as this. I assume they're talking about this one, yeah. Evaluate AB first to get the result of B, then assign that value to variable Z. Evaluates as Z equals A, B. So Z gets assigned the value of A and B is evaluated and discarded. I get it now. So this evaluates the Z to B. And this to A. Most programmers do not use the comma operator at all, with the single exception of inside for loops, where its use is fairly common. We discuss for loops in future lessons. Best practice: avoid using the comma operator except within for loops. Comma as a separator. C++, the comma symbol is often used as a separator, and these uses do not invoke the comma operator. Some examples of separator commas. Comma used to separate parameters in function definition. Comma used to separate arguments in function call. Comma used to separate multiple variables being defined on the same line. Don't do this. So this is not recommended. There is no need to avoid separator commas except when declaring multiple variables, which you should not do. The conditional operator is non-zero, true, then evaluate x, otherwise evaluate y. So if c is non-zero, true, then evaluate x, otherwise evaluate y. It's kind of like an if ternary operator. The conditional operator, also sometimes called the arithmetic if operator, is a ternary operator. It takes three operands, takes 3 operands. Because it has historically been C++ only ternary operator, it's also sometimes referred to as the ternary operator. The operator provides a shorthand method for doing a particular type of if-else statement. Please review lesson 4.10 if you need a brush up on if-else before proceeding. If-else statement takes the following form. If condition evaluation true, then statement 1 is executed, otherwise statement 2 is executed. This operator takes the following form. Condition, expression. If condition evaluation true, then expression 1 is executed, otherwise expression 2 is executed. Note the expression 2 is not optional. Consider an if-else statement that looks like this. It can be written as this. Such uses the conditional operator can help compact code without losing readability. Quantization of the conditional operator. It is common convention to put the conditional part of the operation inside of parentheses, both to make it easier to read and also to make sure the precedence is correct. The other operands evaluate as if they were parenthesized, so explicit parenthesization is not required for those. Note that the operator has a very low precedence if doing anything other than assigning the result to a variable. The whole operator also needs to be wrapped in parentheses. For example, to print the larger of values x and y to the screen, we could do this. Or we could use the conditional operator to do this. So yeah. Let's examine what happens if we don't parenthesize the whole conditional operator in the both case. Because the operator has higher precedence than this operator, this statement would evaluate as. So this has higher precedence than the operator, which makes this assigned to count first. That would print 1 true if x bigger than y or 0 false or otherwise. So I have to wrap it in parentheses, maybe. Always parenthesize the conditional part of the conditional operator and consider parenthesizing the whole thing as well. Yeah. The conditional operator evaluates as an expression. Because the conditional operator operands are expressions rather than statements, the conditional operator can be used in some places where if-else cannot. For example, when initializing a constant variable. There is no satisfactory if-else statement for this. You might think, try something like this. So here is making a constant expression Boolean to false, then an int class size. That is a ternary operator. If it's false, then it's 30, else is 20. Class size should be 20. So if this is true, then 30, else 20. For this, you might try to think something like this. Hi. So this, if b class 1, so this doesn't do the same as this apparently. However, this won't compile and you will get an error message that class size isn't defined. Much like how variables defined inside functions die at the end of the function, variables defined inside an if or else statement die at the end of the if or else statement. Thus, class size has already been destroyed by the time we try to print it. If you want to use an if else, you'd have to do something like this. So I create a function instead. it returns 20, and then if the thing is true, it's going to return 30. Which is a lot more work than doing this. This one works because we're not defining variables inside the if or else, we're just returning a value back to the caller, which can then be used as the initializer. That's a lot of extra work. The type of the expression must match or be convertible. To properly comply with C++ type checking, either the type of both expressions in a conditional statement must match, or the both expressions must be convertible to a common type. For advanced readers, the conversion rules used when the types don't match are rather complicated. You can find them here. I'm Brazilian, Portuguese from Brazil. Can you tell? Just by the accent, apparently. Some people think I'm French. I assume that it's pretty similar, the accent. I don't think I'm gonna read this all stuff. So while you might expect to be able to do something like this, the above examples won't compile. One of the expressions is an integer and the other is a string literal. The compiler is unable to determine a common type for expressions of these types. In such cases, you have to use an if-else statement. So this is different than the other languages because the other languages can't do this. I don't remember really well if Python has ternary operator. For JavaScript, I know it has, and you can do this with JavaScript, but apparently not C++ because of the type thing. No, I'm learning C++ to try, not to try to build my own artificial intelligence library eventually. But before that, I'm gonna go back to studying Python again and SQL, and then trying to build it on Python. Then after I build it on Python, then I'm gonna try to translate to C++. And eventually, I think I'm probably gonna only focus on C++ more because it's more efficient. And I don't care that much that is harder to code because I think you'll probably eventually get used to it anyways. But might take me a while because I'm still getting used to Python yet, and I'm not very good. So I think it might be better to become very proficient with Python first, and then really make the move to focus more on C++ as the main thing, the main language. So when should you use the conditional operator? The conditional operator gives us a convenient way to compact some if-else statements. It's most useful when we need a conditional initializer or assignment for a variable, or to pass a conditional value to a function. It should not be used for complex if-else statements as it quickly becomes both unreadable and error-prone. So best practice, only use the conditional operator for simple conditionals where you use the result, where it enhances readability. Only use the conditional operator for simple conditionals, so it's not very recommended, only for simple cases. I think I'm gonna stop here because of the timer. Conditional operators and floating point comparisons. So I think today is Friday, if I'm not mistaken. Depending on how much I get done today off stream. It's Friday. depending on how much I get done today, I will spend a lot more time reading tomorrow. Maybe I come back today as well to read more. And then if I don't manage to get a lot of stuff done off stream, then I'm probably gonna come back on Sunday and read more on Sunday. So see you then.